Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering. In this video, I'm going to discuss about minimum spanning tree. So normally a tree is nothing but a collection of nodes and edges, and whereas the graph should be a collection of vertices and then edges. So normally this should be the tree. So where I can able to represent, it should be a collection of nodes and then branches. And similarly, a tree can also become a graph. So it should be collection of vertices and then edges, where the graph is going to be presented by set of v comma e. So normally a connected acyclic graph should be a tree, and the tree is going to have n nodes containing exactly n minus 1 edges. So whereas the graph is going to be have n nodes containing less than or equal to n into n. So suppose we are going to tree have a connected undirected graph. So connected means every node is reachable from every other node, and then undirected graph means that so edges is not going to have associated with direction. So then the spanning tree of the graph is a connected subgraph in which there are no cycles here, and this is the connected undirected graph. And the different possibilities of spanning trees that can be obtained from this graph is this one. So where we have to be visit all the vertices in the graph exactly once, so without repeating that. So that should be the minimum spanning tree. Okay, so normally the connected graph means that every node is going to be reachable from one node to other node, whereas undirected graph, so edges going to have don't have any kind of association direction. Then the spanning tree of the graph is going to be connected, as there are no cycles here. And these are the other different possibilities of this spanning tree. So how we're going to be minimize the cost in the spanning tree. Suppose we want to supply a set of houses here, and in this one, so where I can able to calculate the electric power, water, sewage lines, and telephone lines. So in order to keep this cost down, so we're able to connect these houses with the spanning tree. So however, all the houses are not equal distance apart, and at the same time we have to reduce the cost even further. So where we could not connect the houses with minimum cost spanning tree. So normally this spanning tree is going to be used. So whenever I'm going to be use this set of houses, and suppose if we want to supply a set of houses here, then each and every house is going to have electric power and then water, sewage lines, and telephone lines. So in order to keep the cost down, so we're able to connect these houses for the spanning tree. However, all the houses are not going to be equal distance apart. So in order to reduce this cost even, we could not connect the houses with the minimum spanning tree. So see here, a cable company want to connect the 5 villages with their networks, so which currently extends to the market out down. So what is the minimum length of cable that is needed to connect all the houses here, all the villages? So for this, uh, from this village to Cornwall, so the cable length is going to be 5 meters, and Cornwall to Downstream should be 4 meters, and here Eden to Downstream is 2, and Airport about 4, and then Eden to 4, and Finley is distance. So these are the various villages where you can able to connect cables. So what is the minimum uh, uh, cable that is going to be required to connect all the villages? So for this, a minimum spanning tree came into picture. So for this, so normally the graph may be the connected one and then undirected graph. So where n should be the set of vertices and a should be the set of edges, and each edge has a given non-negative length here. So the problem is to find the subset of t edges of the graph, such as that all the nodes remain connected when only the edges in the tree are going to be used, and the sum of the all edges in the tree should be as small as possible. So since G is connected, there should be at least one solution must exist here. So for the given undirected graph, so we have a set of nodes and edges, and n should be the set of nodes v1, v2, v3, and v4, and edges. Okay, so this should be set up. The problem is to find that you have to find this subtree of the edges of the graph. So subtree I'm going to find from this one. So in such a way that so the roads remain connected, uh, and the sum of all this length edges should be minimum one. In such a way that we have to be select the edges of the graph. So normally for finding this spanning tree, I'm going to have two kinds of algorithms. So many first thing is that Kruskal's algorithm and Prim's algorithm. So normally these two algorithms are going to be used to find the minimum cost spanning tree, and both are, should be the greedy algorithms. So for that we are going to have Kruskal's algorithm, so which was invented by Joseph Kruskal in 1957, and Prim's algorithm is going to be invented by Robert C. Prim. So these two algorithms are going to be used for finding the minimum spanning tree. So let us consider this problem again. And so how we are going to be identify the Kruskal's algorithm and Prim's algorithm, using that how can I able to construct the spanning tree here. So for this one, same model I'm going to construct. Let us see what is the Kruskal's algorithm, how it will work. So first of all, what I'm going to do is that, so whatever the edges is there, that should be I have to consider first. So in this one, so this one, that is BC equal to 5, and EF is equal to 8, and CF equal to 6. Then AB, and then AE, and AF. So once that one is done, then I am going to write CF. CF already written. So CD, and then DF, and DE equal to 2, and EF should be 5. So initially I'm going to the list out all the edges here with weights. So once that one is done, I have to be sort these edges according to the minimum cost. Okay. So for that, what I'm going to do is that. So what is the minimum one? So ED or DE. So that should be the first one. And next minimum is that AB. And next minimum is AE and CD as well. And EF is the next one. Then CF6 and AF7, EF8, and finally I have BC. So BC already there, and then BF and FD. FD I'm going to be considered. So this should be the DF. So once I'm going to list all the edges in this ascending order, then I have to consider all those edges in the graph. So by marking this, so this is the first one, AD. So I'm going to mark with, and next one is that AB. So AB is the next one. So that's why I'm going to consider this one. And next one is CD or AE. So that's why I'm going to consider CD first, and AE also same. So AE also same here. And next one is that BC. So if I'm going to consider this, so it is going to be form the cycle, so that should not be happen here. So in order to avoid that, so I'm going to select the next one, that should be EF. So next minimum is EF, right? So that's why I'm going to consider that. And so all the wedges are visited, and then it should not be selected FD because it is going to be form the cycle, and AF may not be selected, it is also going to form the cycle, and DF also going to form the cycle, and CF also going to form the cycle, and BC also going to form the cycle. So that's why I'm going not to select all the edges. And what is the minimum cost? It should be 2 plus 3, 3 plus 4, 4 plus 5. So totally 18. So 18 is the minimum cost of the spanning tree. So like this, we are going to be construct this spanning tree according to the Pascal algorithm. So first, what I have to do that is that, so it generally lists out the edges uh, with weights, and then sort it into ascending order of edges. So once that one is done, sometimes how to mark this. So ED is the first one, next AB is the second one, and then AE. So AE I'm going to consider, and then CD 4 is the next one, and BC, if I'm going to form the BC, it is going to form the cycle. So that's why I'm now considering this, and EF is going to be considered. And then CF means, so it is going to form the cycle. So all are going to form the cycle. So according to this, so this should be the resultant spanning tree. So that is the first step, ED and AB, CD and AE, and BC is going to form the cycle, and the solution should be the sum of all the edges weight. So and this should be an algorithm for constructing the school. So initially I'm going to be passed the graph as the input and length and the set of edges. So that should be the initialization part. So once that one is that, then we have to be sort all the edges in the graph in increasing length. N should be the number of nodes, and initially the tree should be empty, meaning spanning tree. And initialize the end sets, so each containing the different element, and apply the greedy algorithm, and find out the shortest edge not yet considered, and then assign this what is the edge here. So if it is not in that, so add it to the subtree until the edges is going to be written. And what should be the time complexity of this critical algorithm is that, so for sorting the loop, it is going to consider a log n, and initializing the components and finding and for merging, so a log n. So finally, this should be the algorithm complexity of this critical algorithm. Then how are we going to construct this Prim's algorithm here? So in this Prim's algorithm, we have to be consider the vertex here in such a way that we have to be select what is the near minimum viable edge is going to be selected. So in this one, for first I'm going to consider a vertex A. So select the shortest edge connected to that vertex. So from A I'm going to have three edges. So I have to select the next vertex in such a way that that should be the minimum one. So AB is 3 and AF is 7 and AE is 4. So that's what I'm going to say that is. So I have to be select in such a way that so that should be minimum one. So AB is going to be considered, and the next one is that AE. So next minimum is 4. So that's why I'm going to connect this. And from E, I'm going to consider ED. So from E, I'm going to have ED and EF is there. So, but it should be the minimum. So that's why I'm going to select this H. And from D, I'm going to have 4 and then 8 and then 2. So 2 already listed. So out of these 4 and 8, so 4 should be minimum, right? So that's why I'm going to select this one. And from C, if I'm going to select C, it is not going to be considered. And if I'm going to consider 5, it should be going to form the cycle. That's why I'm not going to select this one. And next minimum H, what is the going to have from E to F? So that's why I'm going to consider this one. So finally, the solution according to the Prim's algorithm is also same. So that should be 18. Okay. So like this, we're going to construct this Prim's algorithm. So what is I'm going to construct is, so initially going to be start from one vertex, and from that vertex we are going to be select the minimum vertex that is going to be selected. What is the minimum vertex? And that should be B. So that's why I'm going to construct B first, and then next minimum weight is going to be also from A only. So that's why I'm going to select that one also. And from E, I'm going to have two options. Either I can able to select F or I can able to select D. So, uh, but this should be the minimum one, right? So that's why I'm going to select DED. And next one, DC is the another thing, and EF. So since if I'm going to select EB, so it is going to form the cycle. That's why I'm going to select this. And what is the algorithm for this one Prim's algorithm? So function prime. So here also going to be the graph should be the input and length of the graph, and final set of the edges should be the initialization, and initially the tree should be minimum null, and we're going to select the arbitrary number of n, so until the minimum length such that u should belongs to b, and the t we're going to be matched with the tree. And complexity is that, so outer loop and inner loop, so that should be the time complexity should be and square here from the Prim's algorithm. So let us consider another example. So we're going to construct this. So in this one, what is the minimum age? So that is 1. So that is going to be selected first. And next minimum is that 2. So 2 is how we're going to select this. So how we're going to construct this one. So according to Kruskal's algorithm, so initially I'm going to write all the edges, the HG, and next minimum is that GF or CI. Next minimum is 4. So that's I'm going to construct AB, and 4 I'm going to have CF, and next one is 6. So IG. After that, so I'm going to select HI, and CD is also 7, and 8. So that should be BC, and AH is also 8, and EF should be 10. Before that, D is there, so D equal to 9, and EF 10. Next one is BH. Finally going to be DF. So according to this Kruskal's algorithm, I'm going to consider all the weights in ascending order. So that thing I'm going to map it here. So first one is HG, that should be 1. And from GF, I'm going to select 2. So this should be the next vertex I selected. And next one is CI. It is not going to form the cycle. AB, 4. And then CF. So it should be also 4. And IG. So if I'm going to select this IG, so it is going to form the cycle. That's why it is not going to be considered. And HI. HI is also going to be form the cycle. So this one also not going to be considered. And CD. And BC. AH. Like going to consider, it is going to form the cycle actually. DE. EF. It is going to form the cycle actually. BH. So if I'm going to select this, it is going to form the cycle. And DF. So finally the result one is this one. So they selected this actually instead of this. So like this, I'm going to construct the minimum cost spanning tree. So what should be some of the weights? It should be so 4 plus 8 plus 1 plus 2 plus 4 plus 2 plus 7 plus 9. So it should be 10, 15, 21, 37. So that should be the minimum cost. So how are we going to be select this and according to the Prim's algorithm? So for this, so initially we are going to have a set of edges here. So according to the Prim's algorithm, I'm going to do. So initially I'm going to start it from A. Okay. So AH and AB is there. So AB is 4, and that's why I'm going to select this. And from B, so from B also it should be 8. Otherwise I can able to select this 8. So our next one is HG, and this one is 2. And from here 4, 14, 10. So 4 is going to be selected. And from here I'm going to select C, I, and C6 is going to form the cycle. So I'm not going to be use this. And from 6, C, CD, EI, EF. So sorry, instead of this one, I can able to select this 9. So this is the resultant final tree according to the Prim's algorithm. So here also the minimum cost should be same. That should be 37. Thank you.
Like, share and subscribe. hit the bell icon for more updates.